Once my phone turns on, I used it, and then that's
Just build off of what I say. If I don't...
So do we only have two teams here,
address
is
something,
it officially, or do you guys sort of combine teams since we never always have everyone?
You should
around?
just start making it mandatory and they lose points if they don't come.
Yeah, well, we have the
Besides-
videos so people can kind of supplement as they need to.
Okay,
because
well,
sports
besides
and whatnot.
sports, I mean.
I hear you. I hear you. All right, let's go to start over here with you guys. What sections did you have?
We had pages 148 to 150, so it was mathematics, art, and culture.
Cool.
No, wait. It was like the last little bit of mathematics, art, and culture.
Okay.
Then mathematics as an abstract language, and then mathematics and statistics.
Very good. And what's nice about your section then, I kind of wish, did we have someone here that's earlier than that? Did you have
What
earlier?
team are you?
4.
Yeah,
we're team
before.
You're team 3, so you do have, well, let's start with the earlier team. Sorry, I didn't even think about that, but yeah. With the earlier sections there, because you are art and culture then, correct?
Yeah.
At least you kind of cover that. So that'll be good because last week I had a few slides that I wanted to show in a little video clip, and I'm gonna go ahead and wait until we get to the visual arts, and we'll come back and connect it to math. But you guys can be the ones that sort of segment that with us now, and then you would be a great segment for statistics, which is actually this week's. We're going to be talking about how math interacts with statistics and the use of statistics for various things, but I don't want to get ahead of myself. Go ahead and get started. Tell us a little bit about your section, what you found out, why it's important to society, and give us your question.
It starts off talking about the golden ratio, pi represented by 5, which is 1.618, and it talks about how it's apparent in nature, and then there's the, gives examples, numbers of petals, and then it talks about, it says that it just supports the fact that mathematics is found in nature, and I guess supporting that it's logical. And then it talks about axiom sets, and which is our unrefutable truths, or unrefutable is axiomatic. So.
Good.
And it just gives an example of that postulate about beehives.
What about the beehives?
It's like.
Go ahead.
It just says about the postulate set. Every hive is a collection of bees. Any two district hives have one and only one bee in common. Every bee belongs to 2 and only 2 hives, and there are exactly 4 hives. And then the thing was to show that each postulate is absolutely consistent. And then
Did you do the exercise?
you can.
There's
Oh, you did.
there's 4 hives, and each hive, the first hive, 1, 2, 3, 4. There's 4 hives, and in hive 1, there is bee A, B, C, and then 2 is A, D, E, 3 is B, F, E, and 4 is C, F, D. And those are the ones.
No idea what you just said.
Well,
so.
those are the variables are. Yeah.
He's
So
gonna
the
explain.
variables represent each of the bees, like B A, B B, B C.
Oh, gotcha.
And these are the variables that have to be in each hive in order for each postulate to be absolutely consistent.
Gotcha. So you were setting up what bees wear by using variables
Mm-hmm.
in order to satisfy
The postulate.
postulates.
Condition.
Yes.
The conditions. Good. And if even still you're kind of lost, there is solutions on page 309. There's different solutions. Did you look at that, or did you just?
I looked at it. I tried.
You
to
tried,
figure it out,
and you couldn't
and
figure it out yourself. So you found one of the solutions and does it make sense once you found? And this is pretty advanced things, trying to go from the series of postulates in order to arrive at some sort of consistent set, something that satisfies all of these requirements. And that's all that the exercise was doing. It's not something I could do either. I'm not math oriented in general, so this thing was like, when you even started talking about beehives and bee A1, I'm like, whoa, I need to see it. I once was given, I had Mr. Baydala for my algebra B or algebra 1, I don't know. That was how bad it was. I didn't go right into geometry. I had to do algebra B, and then because we were on the block schedule, I could do geometry right after that. But he sent me to a math competition because I was that good amongst the algebra B people. So I thought it was like, hey, this is great. And then I went to it and I was sweating bullets. I was this little freshman. I couldn't handle this. And the thing would pop up on the screen, and I would blank out every time. And I'd want to, because I was good at just writing everything. I was very visual. I was a very visual learner, and so I needed to write everything out. Whereas everyone else was like, and they just quickly in their head, and then fix it and then do the answer. Yeah, like, no. I have to write the
No,
answer.
no.
Let me write the question first. I'm like, and then I do step one. Everything to me was just about like following the steps. Never mind justifying the steps or figuring it out, working backwards. Like take this answer and create a postulate or some sort of axiom about it.
Multiple choice, they give you the answers. You
Yeah,
just-
there you go. The multiple choice.
Sub it in and
you
it
just do that
works.
nice little circular argument for is it A? No. Is it B? No. Till you get to it. That's why math really, just like anything, really shouldn't be multiple choice because that's why my test, to your, ever dismay, I guess, my test wasn't this multiple choice thing. It was, hey, I had to write about it. Some of you
Wasn't
guys
that
wrote lots of
video?
good stuff, and some of you guys were like, I don't know. I had someone literally on like 4 or 5 questions go, I'm so sorry, Mr. Morris, like over and over again, I'm so sorry. Like this one is like so sorry. I'm like, why don't you just try? But that's the point of the
internet.
free response. It's like, try, you might get some point, you might realize how easy I was at grading it. So, by the way, I do have the grades in for that, not to do tangent, but I do have the grades in. So you can look at those. Those are the raw scores, and so what I'm going to do is go to curve it to the highest grade. So the highest grade was a 94%, so it was really good. So somebody hit the highest there. There was 2 of them. There was 94 and 92%. I'm going to go with the higher one there, the A range. So at least it won't be all 100% points, but each question was worth 50 points, so that's kind of how it works, about 500 deal points together. So. Hi. Kyle, do you have anything to add before you leave? Or, because we had a conversation a little bit. So make sure you have your notes. Did you turn them in? Okay, so you got to turn those in on Monday too, which is today. Okay. Why is math important? Is that all you had on
Yeah,
your
that
section?
was a short.
Okay.
Yeah,
So, can you summarize your section then for the other teams so they can take some notes right now on your section on math and art? You would just talk about pi. Is that all there is to?
Well,
The Fibonacci sequence
They talked. Yeah, that.
and
This wasn't
nature.
Why is Fibonacci and pi? Why are these formula? Why would
Phi.
they have anything to do with art?
Phi.
Well, in art,
Phi?
there's phi. It's a Greek letter phi, which represents.
For what?
That's the golden ratio.
Oh, for Fibonacci. But is that all you were talking about? Phi? Oh, you never said pi. Why it's so funny?
Because Andy laughs so much.
You look so confused.
Oh
but
my
really-
gosh, like what's that?
I know what phi is.
You just look so
Do you all
confused.
know the Greek alphabet? Would you like to hear it?
Yeah.
You know the Greek alphabet?
Oh no, I thought
She
you
said
you'd like to hear it.
I had 2 questions there. Yes.
I don't. Oh. No.
You know the alphabet?
I
again?
would like
it's the first
alpha.
4 letters.
I have a song. I
Gamma.
have a Western song. Alpha, beta, gamma, delta, epsilon. Zeta, eta, theta, iota, kappa, lambda, mu.
I'm gonna learn.
C, omicron, B, rho, sigma, delta, epsilon, B, keep, C, omega.
I'm glad that's recorded.
Yeah,
because
no,
now I
I-
can go learn.
Alright, so that's exciting for you guys. Enjoy that. Next time I have a Hebrew one too, so I can do that.
Oh,
A little
gosh.
Jewish Sesame Street. It's like this jazz song. It's like this clarinet. Oh, wow, okay. So yeah, phi is the sign for Fibonacci. Now, why is it that this formula has anything
Oh, it's
to do
phi,
with
not phi.
art?
I thought it was phi.
Depends on
Whatever,
who
who
you talk
cares?
to.
Uh-huh.
Talk
I
to
was
a
just
Greek
wondering.
person, it's phi.
I was not thinking that.
Is it really?
It's alright.
I was like.
I'll call it.
That's another that's another discussion. Go ahead.
Oh.
Okay.
What's up with Fibonacci? Give them some information.
It's like the.
What's up about it?
Yeah, what's up about it?
Okay, so Fibonacci was the nickname of a man named Leonardo da Pisa.
Okay.
He's spelled
In the
B-I-S.
12th century.
Leonardo da Pisa?
Yeah, he was from the you know where Leaning Tower is? That's where Leonardo was from too.
Okay, so the golden ratio, which is 1.618, was found in nature, which shows how math was discovered, not invented.
Okay.
And let's see, 1800s. It says it's clear that axiom sets are not constructed differently. That was said by John's. I can't even pronounce the name.
Just move on. What you're doing is fine. What is the Fibonacci sequence, and why is it important to this section that you're trying to summarize for us, not just facts?
Okay, so the Fibonacci sequence is a pattern
Okay.
that was found a lot in nature, such as flowers and seashells and the male bee, the family tree of the male bee.
Okay.
And it
This is not going to be square, just to let you know.
it was it's a big part of art because and architecture too, because it helps to. I don't know actually what it is for architecture.
Oh well, it's a ratio that makes.
Like the most pleasing.
Yeah, it's
not-
pleasing to the eye.
The most pleasing to the eye. Why is it the most pleasing
Because
to the
it's
eye?
kind of like a perfect ratio. Like a piece of paper, I think, follows the Fibonacci, the golden ratio.
Tell me.
It's
Why?
1 to.
What is it?
I forgot what
I have a piece of
It's
paper.
square.
Yeah,
and
I
you divide
forgot
the
what
square
the
to make
two-
a square out of another out of the rectangle, right?
I make a square.
Make a square out of the rectangle that you have.
Oh, you cut it to 1 to 2.
And then you make another square
So how?
out of the.
Come here and show me.
I don't
trying to
remember.
figure- I'm trying to
I
figure
looked at a
Did-
video
You
on
don't
it
have the page.
like
you don't have the pages.
3 months ago. It wasn't.
I think if you just keep cutting
It's
Okay,
just
well,
you just keep cutting it out.
Yeah,
It's
you
it's
make-
5 and it's a 5 and 3 ratio, right? Okay. So you
Fibonacci.
don't remember what the Fibonacci did, huh?
1
Alright,
plus
so
1
let's
is 2.
say that-
1 plus 2 is 3.
Spiral.
3 plus 2 is 4.
Oh, okay. So the ultimate Fibonacci equals spiral. Write that down, just so that you know what it is that we're trying to accomplish with.
So you're
our
gonna make a
Fibonacci
square out
sequence.
of that rectangle.
So I'm not going to do a real Fibonacci. I'm just going to do a visual symbol of it because I don't have time. I want to move on.
So you're
But-
gonna make another square to that.
Yeah, so it would be like basically taking that ratio and either having it or putting it in some sort of Fibonacci sequence. So each one goes down and it's like spiraling down. I think I'm going to screw it up now. Where would it start with? I think I'm going to go this way.
Do another square.
I'm going to do this. I'm going to go like that. I think I messed it up though.
1, 2,
Is
3.
that going to work? Something like that.
This
Yeah.
is your job.
This is what's not-
Yeah, and
Anyways,
then cut the
um,
the right to the square.
This keeps going. I have a video and we'll watch it in a second before you guys go. But the Fibonacci is a beautiful thing because as you go, it actually is a great way of describing how it is that something spins around. It's a spiral that we see all over nature. So you can see, you can actually overlay the Fibonacci sequence, the sequence of ratios that have into infinity that create this type of spiral. It's basically not a spiral that goes out from an equal distance, but actually will come out and keep going exponentially larger in its distance. So Fibonacci discovers this as the underlying feature of it. Everything from pine cones to seashells to broccoli to trees. And so when we say these words, and Leonardo da Pisa then is describing this as a definitive proof that math is, you said, blank, not blank. What was the thing that you said about it? Discovered, not invented. Now, is that true? That might be something we continue to investigate because Leonardo is still working under a worldview, isn't he? He's from the 12th century. He believes that there's implicit design, right? He's more than likely, he's from Pisa. What do you think religion is he? Leaning Tower of Pisa, the baptistries of Pisa. Baptistries, baptizing. What religion is that?
Christian.
Catholic, Christian. Okay, so we got some Roman Catholic going. So there's an implicit design there. So he would be a definitive proof for him that this is discovery, not necessarily invention. But what might be an alternative view of the Fibonacci sequence? Why, in fact, is this perfect, quote unquote? Why is the Fibonacci sequence perfect, or it looks beautiful? Is it because it implicitly or objectively is perfect? Or is it perfect because we, as humans, love the patterns that we see all around the world and are simply putting language, inventing, I should say, language to describe the thing that most pleases us? What if an alien had come down from a different dimension maybe, or from a different set of axioms, and they look at the Fibonacci sequence and go, what design are you talking about? That's not design to me. That's something else.
Oh,
So,
I found
we as humans can only talk at what?
That's what I found the proof
Oh, you found the proof for it. Very cool. Is it something that we
It's
benefit from, or is it just...
Well, it's similar to what you showed, except it's just saying.
I think I did it right as I'm looking
It's
at
kind
this.
of it's that except in
Yeah.
a mathematical like.
In the mathematical way. And there's like a branch system, and then there's a series system, like a pyramidal system that they have with it. But it looks something like in your book on page 143. So go to write with what I just said with the Fibonacci sequence. Write page 143, just so you could reference it in the future when you have another test on that. Okay. Do you want to look at have you guys ever seen Donald Duck in Math Magic Land?
Yeah.
Yeah, no?
No.
Give me 1 second, I'll pull it right up here just so that you guys can see it. And then we will move on to our next section here. I just want to give you guys, since you guys have brought up the Fibonacci sequence, here's what I was just saying right here with the Fibonacci sequence. There it is. Nicely shown inside a seashell, and you can do this with any type of seashell. In fact, that's what Mr. Donald Duck here is going to tell us about. So you're going to learn a little bit of TOK from Donald Duck. I showed this to my art history students because when we talk about Greek art, this is very important to Greek art. So take a look at, someone had asked the question, what does the Fibonacci sequence have to do with architecture? And in fact, it has quite a bit to do with architecture, as soon as I get this stupid thing. Come on. Play. There we go. No! No! Wait a second. Oh dear. I'll just edit this out of the video. I have to just keep it on there. I can't touch it. Alright, not touching it. Donald Duck. Oh, I have to turn off the music. Oh, I thought that was part of it.
Yeah.
Yeah.
No, this is like trippy Disney stuff. Okay, so the star, they start with this simple shape, and they're talking about ratio.
Proportions of the famous golden section.
There's your golden section, which is the visual representation of what we are talking about with
Once again, we have the
Fibonacci.
golden section.
Now, what is it? What could that also look like?
Hidden within the pentagram
Strings of a
is a secret
heart.
for creating a golden rectangle, which the Greeks admired for its
We
beautiful
admire-
proportions and magic qualities.
admire these
The
shapes
star
almost
contains the
religiously.
golden
because we see
rectangle
them
many
everywhere.
times over.
I love that 50s kind of music. Reminds you of childhood, doesn't it? There you go. See, that's what I think.
It's a most
We're gonna hear
remarkable
Donald Duck
shape.
like.
It can mathematically reproduce itself indefinitely.
There's our Fibonacci. They're doing it.
All these rectangles have exactly the same proportions.
So I should have just kept going inward. I think that's what I had messed up on.
This figure also contains a magic spiral that repeats the proportions of the golden section into infinity. To the Greeks, the golden rectangle represented a mathematical law of beauty. We find it in their classical
This is the
architecture.
Acropolis. This is how it has
The
to do with.
Parthenon, perhaps one of the most famous of early Greek buildings, contains many golden rectangles. These same golden proportions are also
On
found
the
in their
porch of the
sculpture.
maidens. So even down to the human form and into the face. Every face had this system. So this was the
In the
symbol of the
centuries
Greek
that followed,
sculptor.
The golden rectangle
Who was
dominated
one of the first
idea
people who
of
discovered
beauty
it in the
architecture
body.
throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world.
So it's like Van der Rohe and other, like, the international
Modern
style that
thinkers have
created
rediscovered the
skyscrapers.
magic of these proportions. Indeed, this ideal proportion is to be found in life itself.
Boy, oh boy, oh boy. This is mathematics.
Alright, so, and then he tries to grab it and it just becomes a bunch of wire mesh rectangles. It disappears. So. Humans are deconstructed to their basic mathematical concept. Alright, so that's what I wanted to show you from last week, so that was a great, actually, recap of that. Do you guys have anything else? That Fibonacci was really important, so make sure you know that. That's one of our central questions, and you could have asked that question, is math invented or discovered? From an artistic standpoint, we might think of it as a discovery from nature, because so much of art is an imitation of nature. That's one of the theories that we will explore when we get to the visual arts. Did you guys have an answer to the question of why is math important to society?
Because it's like, I said because it gives order and structure as a way to like
Consistency,
maintain.
right?
Yeah.
Order. We like knowing. Don't you love going to math class sometimes after all the gradient of English and just all the, and to just know that you don't have to, sometimes you don't have to think, at least the way that it's presented often, unfortunately, or fortunately or unfortunately. It seems nice just to kind of know that there's x equals something and that works. And the system gets completed and it's a nice little loop and you're like, ah, thank God for circular argument. But it just all kind of fits together. And so yeah, we kind of sigh relief because it gives us order and purpose. I felt that way too in math class, despite my weakness in it. Very good. What else? Is that it? That's the only reason why it's important?
Statistical, like how you said the guy predicted.
Yeah, so Nate Silver, right? Those who weren't here last week, Nate Silver predicted what? Do you guys know who that is?
Oh,
Yeah. He predicted the election with 90.1% accuracy using statistics, and the pundits, like I mentioned last time, freaked out, both on the left and the right, because how dare you? It was neck and neck. Well, that's, of course, their worldview on that, because they need people to watch their shows. You need to watch the shows to know what you believe, but Nate Silver was able to figure it out based upon how people in the past had voted, and he was able to predict 100% accuracy every single state, and with a 90% probability that Obama would win re-election. So statistics are important for that regard, even if people disagree or reject it or don't use it. So those are good. So those are good thoughts. So predictions and that statistic thing, hold on to that because that's what we're going to cover this week. All right, good. You have a question to pose to us?
Read it. Is mathematical truth the only type of knowing that provides rational, logical, and unequivocal truth?
Where does your bias lie? Yeah. Is math the only perfect way of knowing?
Well, that's what we were deciding. We're like, that sounds like it's assuming that math is.
No, but I understand that. And that would be something if you wanted to explore if that statement is actually true or not, or if you wanted to pursue the assumption that math is the highest knowing. I think our book actually assumes that. So it might say, it starts with the idea of math seems to be a higher, in fact, the whole TOK premise in the curriculum, if you look at our curriculum guide, it assumes that math is sort of the best way of, the most rational way of knowing. It just sort of assumes that. And so I've challenged that a little bit with a couple of things. Not too much, because I don't know enough about it, but with the idea of change over time, the history of mathematics, for instance. So, anyways, good question to think about. Is it the only one that's as high, or is there some other way that we can get to the level of exacting quality of math? Interesting. Okay, so something to think about. Next group here, let's go ahead and talk about your section, like I wanted to start with, but it'll make more sense now. So go ahead and get started.
Okay, so
General observations.
General observations. Well, yeah, I'm just going to pull one sort of idea from each section that we read. From the first one, one thing that was pretty interesting was it was talking about how math really it's the same across cultures. Like it's something that connects us, and across areas of knowledge too. So it's sort of like a universal thing where it doesn't really change much when you go around the world. Like, math is math. It's not like there's an English math and a Spanish math and a French math. It's just math.
1 plus 1 equals 2. Even if I say uno, what's plus in Spanish? Quick. I don't know. What? Mas? So, okay. Of course. Uno más uno. What? Estos is. Estos dos. Okay, so it doesn't matter if I'm saying it in English or Spanish, 1 plus 1 equals 2 is the same, right? Seems to be. Okay. So there's consistency. So make sure you have that written down. That's the key word of math. There's consistency across cultures. In some ways, then, it transcends language, doesn't it? Maybe it's its own set of language. Oh, with symbols. We have symbols. You look at that nice little chart there about
The
symbols.
next one is like about math as a language.
Okay, cool. Go for it.
So, we've all been in math class. We all know that math almost has like a specific language. We can communicate so many ideas through various types of symbols. I mean, in math we can look at the symbol of pi, know that it means 3.14. We can look at E, and we can look at like a complex number like a plus bi, and know that I is like root negative 1. Like
What?
Yeah,
Yeah,
it's just like
go for
different
it. Yeah, root negative 1, of course. Go for it, yeah.
But yeah,
Keep going.
It's a pretty abstract language, but we can communicate so many ideas through it. Let's see, and also we can communicate a lot of things through charts, tables, graphs. It's all through math we can just by looking at something we can tell, oh, this means that. Even it's almost
Yeah.
you learn this stuff from.
Do you think that the development of the symbols of math are self-evident, like they just sort of were discovered, or do you think it had to do with perhaps culturally we all sort of got together somehow and decided on what our universal symbols were?
I don't think it would be discovered.
Yeah, like the plus sign.
Well, when you say discover, it means like you found it, but they gave something and they gave it a symbol to represent it.
Yeah. Okay, so
Just as we give a picture of a man to symbolize a man.
Sure. So then the question is, because you're talking about the symbols as being sort of connected to a universal language, I think this has a lot to do with when we carry over between math and language, which is itself a different area of knowing. Language communicates truths. Those truths are different than the language that we're using. There's some sort of separation there, just like our senses are different than the thing out there that we're perceiving. And is it the thing out there that's universal, or is it our perception of it that's universal? Those are the questions of TOK. So you're talking about consistent language, but could it be that that consistent language was created or like sort of developed? Real quick, what was the first way in which you learned what the number 1 was? What's number 1? Show me. Okay. What did you guys all do? Your finger. Your finger's number 1.
Yes.
Well, it's a representation of 1.
It represents. So it's a symbol, right? And as a child, you learn 1, 2, 3. And your parents probably told that to you, like, you're gonna get over here. Okay. All these languages that we learn. We call it kinesics, our body language. Anyways, 1. Now, if you learned it in Germany, you wouldn't have put up your index finger. What would you put up?
Your thumb.
Ein. So, or in France, dude. My son knows how to count to 10 in 3 languages, about to be 4. I'm sorry, he's still in 2. So I'm trying to teach him to do it because I like the European way. I like going from 1. Because it just makes sense to do this first, right? Because then you're like going, you mess up. So
usually go. But it's harder to hold like 2, 3.
You're like 1, 2, 3.
Can you make it though?
How many? What are languages?
Huh?
What languages?
French,
Wait,
Spanish,
can you do
and English.
Yeah, I thought you weren't gonna say English.
Yeah, French, Spanish, and German. He doesn't know
I
English.
can't even
So
look.
we're still
I can
learning
barely
that. He
do
doesn't know
it.
yet.
What?
But anyways, thumb is number one, right? So in fact, if you do it the wrong way, you might actually get shot in a Nazi game of
Yeah.
Who Is It, like Inglourious Bastards. Didn't that happen?
Yeah.
Anyways, so you learn it different ways. So the language changes. In fact, there's other ways too. You can actually go 1, 2, 3, 4, 5, 6, 7, 8, 9.
Whoa.
You can have
You count to 20.
2, and then all of a sudden you go boom, 20 right here instead of just 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should do that. You can do 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to show you something.
Uh-oh.
Would you like to know how I was screwed up as a child? Here we go.
Yeah.
This is the math system. This goes back to math as education. What is that? How do I count to 9? I'm a first grader. What can I do?
Or you can just like do that.
Okay, this is what they taught me. 1, 2, 3, 4, 5, 6, 7, 8, 9.
What?
That doesn't make sense.
That's so confusing.
Why do you?
Would you like to hear? Would you like to see a 6?
Yeah.
1, 2, 3, 4, 5, 6. So it's like you do it twice, 2 dots, and they had this nice
You know
little
what
chart.
five? What do you do for five?
Wait, what does that even mean?
Yeah, no.
I know
Yeah,
5,
no.
4.
How do you know what to do?
1,
One,
2,
two.
3,
How does that help you
4,
at all?
5.
Yeah, I remember that.
Yeah, how does that help?
Does that show you that
Okay,
number
so
6
instead
represents
of-
6?
When you do larger numbers, when I have to add 2 numbers together, so let's say I do 5 and 6, I just go 1, 2, I go 1, 2, 3, 4, 5, 1, 2, I go 5, 6, 7, 8, 9, 10, 11.
Why can't you just like know the 5 is 5
No.
and then just add them?
But you can count it.
Like, oh, like instead of like counting.
Instead of counting with my
Like,
fingers,
oh,
it's when I get a higher
okay,
number.
okay,
So,
okay.
and it only really works with, your first. Anyways, you're right. It's like, why do this? And even up until like trigonometry, I'm sitting there going, like there are these taps, I'm telegraphing like SOS, I suck at math. I'm still counting. I'm using a crutch like fingers. Yeah, so that was
I remember the test for like
my math.
No, my grandparents gave me like songs of like multiplication tables, so like,
Yeah.
like to this day I have to like sing songs.
Oh,
No,
Oh
I
my
learned
God.
like
Did you?
I learned a bunch of multiplication things in Schoolhouse Rock. Like
Well,
the eight.
yeah.
Yeah.
Eight's okay. What is it?
Huh?
What is
Oh
it?
no, no.
You do
It's
know
like
it.
some figure 8 song. And it's like.
Last week, you look at the slides here. I had a system of how Japan they check. It's called a line system of multiplication. Look at that. I don't know how to do it because I've never done it, but it's basically like if this is 12 times 13, they do something like this where it's like.
You write the one,
Could do
you
it
make
in
one
under
line,
minutes
and then you
post.
write
And then you like.
2 lines, and then you do another line, and then you do 3, and
Yeah.
then all the intersections.
And they have this system. So the question, because I think the book assumes a sense of consistency, but at the heart of how math operates, or the purpose of math, is it not that there's
With like
quite a bit of variety, at least in the way that we use math? Is that too much?
My songs.
Okay. Just use your songs, but know that Japanese people have their own songs. Or Hebrew people use their own songs and things that they do. So just think of it like that, okay? All right, no more. Okay. Anything else from your section?
If I studied it,
No,
like,
my-
Oh yeah.
Yeah.
I have to go,
You have to leave.
I have to go pick up
It's just
another
in the
well,
wheel.
also
Oh, shoot. Okay, we'll be 4-4 like right now, or
before 4.
okay.
In section.
whenever you gotta leave.
I guess their daycare closes at 4.
Oh, you're gonna miss a fun one. All right.
What's the fun one?
Look
We're
at
gonna
there's
have our look in.
puppets.
Let's make it. We gotta get to this, so hurry up, Sarah, and we'll get going.
Oh no.
Yeah, watch the
Right,
video.
and
I'll try to,
Oh.
like,
In the last section, one thing that they discussed is how
Invitation from Elizabeth
people gain,
Lewis.
different perceptions on how math is represented. Like one of the examples it gave
It's still playing,
was
right?
it gave
It's still
like
playing.
2 different
recording?
ways to if you say you have like a graph, right?
Uh-huh.
You can either number by like 1, 2, 3, 4, 5, or you can like smush it and go by like 100, 200. You can like
You can change
switch.
the scale.
Yeah, you can change the scale. You can change what area of the graph you're looking at. And so it was talking about how, say, if a business owner wanted to show, oh yeah, our business is growing, they would obviously choose to represent, their data in a way that showed, an
Describes the-
increase. Whereas if they wanted, on the other hand, to show customers that, oh no, our prices aren't rising, they're staying the same, they'd choose to take it to a point where it looked like it was a less steep.
Right.
Like it was it made sense.
Yeah.
And then
How we describe our data in order to show, again, what we want it to show. Which isn't to say that all data is subjective, but that there's an argument and phrasing with statistics, just as there is in any other type of rhetoric, right? So we be careful of those things when we're doing science. Which is kind of goes to my thing today. Do you have an answer to the question of why it's important to society for us?
I don't know. It's something that it has so many practical applications in life, where, you know, I mean, you see it on like a daily basis. You know, the predictions we make, you know, statistics. You see it. You really just see it everywhere. So it's really good to have that background.
Well, let's explore that. Yeah, let's explore that more. This idea of every day seeing this kind of stuff, using math for predictions or consistency. I think there's something that we can talk about with that. 3 ideas for this week. So go ahead and write these down. This is our beginning of our lecture notes now. I know we have about 30 minutes now, a little bit less than that. I swear we will get to everything, and certainly the activity will come before everything else, for sure. And I'm going to kind of breeze through or argue it out for climate change, just because I think it'll be more important to talk about the concept than necessarily its application in this debate. And we will come back to climate change or some other type of contemporary issue when we do science. But here are the 3 ideas for this week, and they're simple. I'm trying to consolidate for you guys, give you a little bit more of a foothold, hopefully, in what we are talking about. Number 1, statistics. Statistical data is the interaction between a couple of different things. So it's science, meaning the what. What are we looking at? And this kind of goes to your last point from your readings about what is it that we're looking at. If I'm a boss of a company, I'm looking at, you know, my customer prices, my pricing for my customers, or my sales, my revenues, and that is the stuff, like the money, right? So I'm counting money. In math, it's the interaction now of science and math together. The math is the how. It's the language, it's the axioms, it's the theorems, it's the formula that we put it through. So we have data, which is our observations, our theorems, which is our math, our how, and then lastly, our epistemology. And again, epistemology, that's why we started with it, because it's the why. Why are we doing this? What's the reason? And this is very important. If you don't understand that there's epistemology in all that you do, you're going to miss your own bias, you're going to miss the bias in others, and you're going to get duped, or you're going to get snookered, or you're going to get deceived, or your intuition, which is one of my points, your intuition will become wrong. And that's so often the point. We talk about how beauteous the Fibonacci sequence is, and that seems to be like just standard because we love seashells and we love these things in the nature. It just makes our eyes feel nice. But intuition is often our greatest foe when it comes to math. And I'll show you some funny experiments in a second. Math is a counterweight then to expectation and intuition. What do I have here as a picture? Yeah, oh, it's good that you don't know this. It means you don't aren't ready to go to Vegas anytime soon. It's one of those things that spins around and I lose all my money.
Is it roulette?
Roulette wheel, yeah. So the roulette wheel. Why is it that people go to Vegas? I mean, besides the drinking and the prostitutes.
Win money.
Sorry, I wasn't gonna see it on here. You get money, right? No, that's not the reason why I go to Vegas. To lose money, right? Because you'll always lose money. But we all think we go to win money. That's the point. And my mom is convinced that she wins more than she loses. I'm pretty sure she doesn't, but she thinks that she has. And she's done a couple payouts, so she might be right. But I'd have to. Again, it's like pictures or it didn't happen. Oh, like give me the data, or else I think.
It doesn't matter what she's doing. It keeps going. That the data's gonna pan out. She's gonna lose her money.
Ultimately, the more she goes, the house always wins. And this is a statistical truth or deterministic thing about the house, unless you can cheat, which they do a really good job making sure you don't. Roulette wheels are the epitome of what you talked about with phrasing of your statistics to make it seem like something, whatever your point is. That's how the house does it, double or nothing. Isn't that such a wonderful thing? If I give you $200,000 now, and I said, Yeah, you can give me this $200,000 now, or you can take $100,000 of it and double your money, and you can. Would you do that? Would you lose that $100,000? Double or nothing?
Like, is it 50-50? Is it like a coin toss?
Yeah, it's a coin toss, right out.
Then
50-50. Would you do it?
No.
You already are going to guarantee to have $100,000. You could have 300. You could triple your money on
Not
one coin
tripling.
toss.
It's not tripling money. You're
Also,
like,
you don't
you're not
keep
even
it all.
doubling.
But would you gamble $100 grand?
Oh, you're doubling.
I'm
Look
gonna
at how so
say it.
easy
I'm
it
just gonna
is.
take it for my qualification.
Well,
It is
you're
a-
going to
yeah,
lose
if I have
$100,000.
If I have a 51%.
I give you $200,000 now, or you double
50-50.
half your money right now.
If it's 51% for me to win.
If it's 50-50,
Sure.
yes.
Is it all just scale? It has to do with, you know, well,
Mr. Ren told us
if I
last
get 100 grand.
Mr. Ren told us last year that
Oh, yeah.
like in craps,
Craps
that the
best
house
game.
has like 51% chance to win and like the person has 49.
It's
And
the
in the
best.
long
It's
run,
the best game to
it's
play.
like casinos make so much money just off of that 1%.
Oh, wow, that's good. So that's craps? So that's what he does, huh?
That's
Good to know.
I remember playing that though.
Last one here, our responses then. This is our finishing of this question. The counterweight of intuition is that the math is often a response to our responses then to mathematical choices regarding risk behavior. So risk. Statistical bias is all about risk. What is risk? It's a board game. What is it? Oh, it's not risk.
Oh no.
Yes, you're absolutely right. Risk is bathrooms. Risk is what?
Is taking something
Yeah, that's
where there's
taking
a
a chance.
possibility.
Assuming that you might lose more than you gain, right? So this might be a question of risk. And risk analysis is very interesting. What might there be applications in the idea of risk? From a mathematics and from a contemporary perspective. What are we just slogging out of right now? Huh? Think of it. Huh? Recession, right? What happened? Why was that recession? What was that
Because
recession?
everyone like put their money into houses. They invest
Risk
their money. They
analysis.
risk their money
For the big
profit.
payout, right? The ding, ding, ding. Okay, so let's go ahead and start this process. I wanted to show you this real quick, and I'm going to skip it very quickly. This is climate change. I'll do it real fast, and then we will talk about it again. This is how climate change could look if I went from a decade to decade description. Now, what do you notice about the way in which the median line is drawn?
Slowly raising.
Yeah, slowly.
Slowly becoming.
It's now you already noticed the real thing going on, which is this. But if I were just to give a section of this, what does it look like each section is doing?
Oh, it's declining.
It's declining. There's a bit of an illusion here, and this is often how climate skeptics will describe the data. They'll look at a 10-year period and say, look, it's going down, and this year it's going down, these decades are going down. They see it in segments. But what ends up happening when we draw the real median across the full series of it, these are the same exact data sets, just with a different median, meaning a different mathematical description, much like you described from that small business owner. How do you describe your chart? What do you want people to see? Here we see a clear description of this thing. Now, what if I did this, as I've seen a couple of news media outlets describe, where they take the lowest temperatures of a section and point those together? You can do something like this, where you're like, look, we're in a cold season. You know, like a colding, it's not global warming, it's global cooling. And you do something along these lines where you like take this number and you kind of go, and you would lose your data set, right? You would lose the consistency in which you describe data. So here it is once again. Why? And this is the GIF that shows how it's being set up depending on how you view the data, right? So there's very different ways of viewing this data. One is, I think, valid, and one is not valid. Wouldn't you say? So here is let's just repeat it. So what makes for a good statistical reading? When we detect and collect data, how do we do it so we're maintaining ethical integrity? So how are we doing it so we're doing it in a way that's actually like accurate and good? It's good in the sense that it's both good data as well as moral data or ethical data. I shouldn't say moral data. Ethical data, meaning I'm not doing it by killing a bunch of things. So this is something that's constantly a problem. How do I know, for instance, that a medicine works? If I do trial runs, can I do it on animals? Is that accurate? Is that ethical? So the statistics connected to animals. Human trials. I read an excellent book that you're going to be reading for your for one of your lit circles next semester called Bad Science. And in it, they talk about the power of placebo. And in the 1940s and 50s, before they had strong regulations on how placebo testing was working, they actually did a knee surgery placebo. Where they took half the trials, said, hey, you know, sign this waiver and we will do an innovative knee surgery to see how much it helps your knee pain. Half the people got the real surgery, half the people got cut open and then sewed back up. And the knee surgery turned out not to be effective over the placebo. Meaning people just thinking they had a cut, meaning the surgery, they felt like their knee was better. So, is that ethical? Is that an ethical way we derive our statistics? It might have been effective for understanding this. It's money savings, so you can think of it like that. You're also saving a bunch of people this surgery that they may not actually need. But at the same time, placebo testing, interesting. So reflect on, how does the data then reflect the real world? How do we get real data that tells us something rather than our own biases? And there's all sorts of rules that we set up in order to do that. Double-blind studies are a great one. When you do psychology, you tell your group that's collecting the data one thing, but you're actually finding another thing in order to prevent that group from collecting data that is preconceived. Answer your goals regarding science. So how does this answer your goals? Are you finding data that's not necessary, or are you finding data that's actually part of your goal? And avoid mistakes of history. How do you know things about the past so that you don't repeat them? We have a body of evidence that describes that. And then there's other questions. How does one interpret data such that? This is all online, so you don't need to copy it necessarily down, because I'm going to go fast. How do we do it so that bias is reduced, understanding is progressing, dialogue is maintained, and then how do we, so actually continuing conversation rather than shutting it down. So my last graph could be, if I were to say it in a certain way, say, all climate skeptics are stupid. But that's not how I would have ever described that data. They're using a different set. I think one's valid, one's invalid. But is skepticism a good or bad thing in science? I think it's always good. So it's good to have that dialogue and to continually to try and clarify our positions. How does one do it? And it relates to ethics, history, emotion, reason, language, etc. I've described all of that from these points over here. So this was, I was going to talk a little bit more about this, but already we've got about 10 minutes left to do my Let's Make a Deal. Here is my activity for us to look at. Who wants to participate? Someone's been waiting to do this here. All right.
He can do it.
Everyone's going to get to participate on their own the last couple minutes of class, but really quick here, let me just throw it. Come on, Sean, up here.
Have you ever seen the Phineas and Ferb episode of Let's Take a Quiz?
No.
I was just wondering if it was like that.
I don't know. I don't know if it is not. So have you guys ever seen War Games by Ferris Bueller guy? He's like, would you like to play?
I want to play a game.
No. Do you guys know that? No.
Wait, what?
You know that? Yeah. Would you like to play a game?
Yeah.
Okay, so fine. Saw. How about that?
No, it's I want to play a game.
Yeah. Okay. Go ahead.
Yeah, you're going to play.
Go ahead and sit down right there. Don't touch anything. Okay. In one of these three cups, there is a $5 bill.
Hey,
Okay.
damn it.
Now, in two of the others, there is a quote-unquote goat. Now, this is how the original Monty Hall game in the 1970s.
What's it
Oh,
called?
there's a new
Let's make a deal. Do they have a new game like this?
Yeah.
Where there's
This is
like
how the
doors.
natural. Hold on, I got only 10 minutes, so I know you're excited, but oh, there's another game that's like this. They have goats. In one of the doors, there's a car, and the two others is a goat. So this is how the game show is set. It's just like Sean. In one of these is a car, and the other two are goats. So, would you like to make a choice?
I want the goat.
Now, first, before we make a choice, what is his probability of getting
1 out of 3.
1 in 3? Okay, go ahead and. Okay, so you're going to do that one. Okay. So you selected your cup. Yes. Okay. Now.
No, you can just switch or stay.
Oh, you guys already know this? You guys are going to ruin this.
I know. Have you seen the video explaining it?
So be quiet. if
I'm
you
not
already
saying
know.
anything. I'm just asking him.
And Sean already knows
Calm
this.
down.
I don't know this.
You get out of here.
I don't know it.
That's someone that doesn't know.
I don't
Yeah,
know
who has no idea what I'm doing right
No,
now?
I don't
Because
either.
you're gonna ruin it.
it.
All right. Yeah, he chose it. You gotta keep with his cup. So here it is. Now he's chosen this cup, and I've just shown that there's something out. You have a chance right now if you want to choose a new cup or stay with your old one. What do you want to do? Now, why?
Tristan.
Why?
Why would you do that?
Because every
In my experience, and especially test taking, my first answer is always right.
So the first answer, this is great, I'm loving this though. The first answer is always right?
There are 3 different scenarios. In the first scenario, I choose this cup with my first choice. Now, remember, Alan knows where the car is, so doesn't want to reveal it, and will always choose to reveal the other goat. But now, if I change my pick, I'll win the car. In the second scenario, I pick the other cup hiding an animal with my first choice. Again, Alan, who knows where the car is, will reveal the remaining animal. I'll change, and I'll win. It's only in the third scenario, when I pick the car, that I lose, because I'll change to an animal. But in 2 out of the 3 scenarios, by changing, I win.